asking else, the power of a tester's mindset. I found currently that the role of testing is changing. In my current company, officially, I'm not a tester anymore. They call me software engineer now because they've merged the two roles. But the mindset of a tester and the skills we need is still absolutely essential. As Maria was indicating earlier, testing is an activity and we need the skills for that. So during this presentation, what I'll talk about are those critical thinking skills, are the creative thinking skills as well that we require as a tester. Now, I have some examples in my presentation where we failed to spot the bug in time. Hopefully, some of the audience is able to spot the bugs or the assumptions or the flaws, the errors in our logic, before I actually come out and tell you what it was we found in hindsight. Who am I? My name is Marianne. In the Dutch pronunciation, that is Marianne. As I said, I work as a software engineer / test analyst at Rabobank. I'm also a Girl Scout. I do a lot of volunteer work, a lot of communication and marketing work, and I enjoy speaking as well. I'm a former teacher. Now, as human beings, we love patterns. Often, when we go to these conferences and we go to the same location, we'll find a spot, the seat that we originally picked. We like this seat and we'll go and sit somewhere nearby. So how many of you have been in this room before? Yeah. How many of you are seated very close to where you originally sat down this morning? Yes, well, you're still in the same first 2-3 rows, I would say. Yeah. We do this at work. At work, we like patterns too. Our users like patterns. Our users like to specify, oh, we want this, and that should work like this. And our business analysts and our developers, they follow this pattern. And we as testers are very easily swayed as well. But our role is to ask the question else, to break the pattern, to think anti-pattern. Are you ready for my first example? Yeah? Now, before I can really give you the example, I have to give you some specifics about my project to help you understand. Because these examples are real-life examples. I have tweaked them a little so that I'm not, giving all the specifics about my work situation. But just to give you a sense of the complexity in which we usually work in, this is our... Keep on hearing myself fade out. I'm not sure if you hear that too. Okay. We process 3 million journal lines per day. I work in a very data warehouse environment. So we have a lot of different tables. We have a lot of different processes, a lot of ETL, extraction, transformation, and loading processes. So the examples that you'll see are also from a data warehouse environment in which data is transformed. Now, there's a lot of logic involved. I won't bore you with all of the details. But please be aware that this is kind of like a river flow of data. And we'll come back to that in a later example. We also have all kinds of different technologies that we use because we don't have a front end. So there's a bit of a mixture in there. Now, first example is a specification example. This came to us. We needed correct value for a column called amortizing given. We also have its counterpart, amortizing taken. Now, this column is built up based on the following logic. It is based on the amount of cash flows with type P or N. And if the leg type code, which is a different column, has the value P, and the amount is equal or larger than 3, and that's the amount of cash flows then, the value is 10. If it is not, the value is 2. The taken is very similar. The only real difference is that there the leg type code is P, and here it's R. For the rest, the logic is the same. If we built this, where could it go wrong? Yeah, it will be either 10 or 2. Mm-hmm. Can there be wrong data in the column? Well, the column, the outcome is either 10 or 2. Yeah, in the leg type code, in that sense, it's either P or R. So there's not really different values that will be inputted there.
Where's the R specified?
Hmm?
The R, where is that specified?
The R, how do you mean?
We have P and N.
Yeah.
Pretty, well, that's specified, but the R, that's, I don't know where it comes from.
Where is the leg type code specified? That's part of the input values that you use for, like, this trade has this amount of cash flows and this leg type code. And it'll always have both. So there'll be a P version and there'll be an R version. Anyone? Where can this be misinterpreted? Well, that's the thing. And the tricky thing with these kinds of examples is that everything's new, so all of the values are questioned. But look at it from a logical perspective. Where is it uncertain? Hmm? Yeah, the rest is the same, but it's not the leg type code. Mm-hmm. The first values? Mm-hmm. Yeah, in a sense, what happens here is whether it's given or taken is defined by the leg code. What we did when we built this, we counted the number of cash flows for that specific situation. So on the P side, that's like, 2 or 3 or 4 or 5, and based on that we decided. And on the R side we did the exact same thing. When we built this, our user came back and said, well, I see inaccurate values if you do this, because for this particular trade, the value is 10, but there are only 2 cash flows N and 1 for P. I expected value 2. So if we go back here, we have amount of cash flows with type P or N, but what is uncertain in this, what can be misinterpreted, is that the original business analyst and user had discussed that if it is cash flow N more than 3 or cash flow P more than 3, you would have the value 10. If either of both were below that, you would have the value 2. What we had implemented was we'd counted the cash flows N plus P amount. It's a very subtle difference. It's the or that isn't quite specified. Is it the amount N plus P or amount N, amount P? But it did go wrong. It was caught way in time, but we built it wrong. And why did we build this wrong? It's because we didn't ask clearly enough what is meant here. We assumed and we interpreted in this one particular fashion, and the business user had interpreted in the exact other fashion, and we weren't aware that we'd made this assumption. There's another story about assumptions. 2 more, in fact. Story number 2. Let's see how this goes. Now, as I said, I work in a data warehouse environment where we have a lot of data transformations. One of the things we do is we match up certain types of data. So to give you the bit of background, we have one source that delivers facility data, and it needs to be matched to the other source. The other source always prefixes their facility ID with the prefix of the source, ABC. We want to match this data, so we need to find a corresponding column. And luckily enough, this source that we're trying to match already delivers a column that contains the value for ABC, ABC facility ID. The only problem is we prefix this one, and we do not prefix this one. So up until this point, the data hasn't been matched. So they've come to us and said, you know what, you need to prefix that one too, so we can match the data. You need to do that for all the new data that comes in. And we also need an update on all of the existing data, because otherwise we still can't match. Where did this go wrong?
Your data got two prefixes.
How do you mean?
Your data got CDE, ABC, and then your data.
No. No. No, because we prefix this one with ABC and we prefix this one with ABC. We don't prefix with CDE. It's awfully quiet.
ABC facility ID, prefixed again with ABC.
I see what you mean. This is the name of the column as it is delivered to us from the source. And this prefixing we do here is something we do in our transformation when we load the data. We use the exact same prefix. Now, if you remember in the previous story, it all just needs the same prefix. Yes.
It doesn't say that both the header name and data, the values in the column?
The values in the column need to be updated. Yes. Well, the header, the name of the column as it's delivered stays the same, that's fine. The problem here is that...
Limit of values?
Hmm?
Is there any limit of number of characters in the columns of the specifications?
No, there is no limits to the amount of columns, so if you do this, they really do match. If you add the prefix, you can match the data, no problem. You're very close. There's one more other step that could also be in this column. Now, what we did is we built this. It worked beautifully. We could match all this data, no problem. The only problem was that if you filter this through all the way to the end of the chain, we suddenly had no facility IDs on our head office reporting for this source. The reason being that we assumed that this ABC facility ID was an ABC facility ID. The problem is that this source delivers the ABC facility ID in this particular field, but it also delivers ABD and FYZ facility IDs. It delivers all these different sources and their alternate facility IDs in this column, which is specifically named as being from that one particular source. We trusted the source on their data, and we didn't carefully examine the data enough. Now, I realize that a lot of these examples are very specific, so you might be thinking, like, how could I have caught this? So let's bring it to an example that perhaps, rings a bit more true to home. We all pay taxes, at least we're supposed to. And banks do the same. They have to pay taxes. On products. So, for product X, Y, Z, we have to pay taxes. Now, if we sell the product, we book the reserved tax payment to a 4 account, and we book the counter booking, because accounting needs to be in balance, to a 1 account. If we buy the product, we put it to a 5 account, and the counter to a 2 account. So far, so good? You're all with me? Okay. If we have this situation, what do we know we also need? Yeah, he knows, so he's not allowed to say. I told him before. We need to know when the tax will be paid and all those kinds of details. You're absolutely correct. We would need that information, but it's not the actual else that I'm looking for. Put it in an if statement, or put it in a given when then structure. What's your central if? Sorry? If we won't sell it after all, so the... So you're in this if you sell it, then it doesn't work. It doesn't happen. Yeah, then you have a reversal, that's true. And then you have more logic. It's an if you want to put in here. If this doesn't happen and it's something else, how does it work? There's a bigger if in this statement. One level higher. Think about your own taxes. You file for your taxes, what happens? If you're lucky. When it's not filed. No, you know, when you get it back, if you pay taxes or if you have to reserve money to pay taxes, you know that at one point you're going to get a transaction where you get a refund. Which, as you said, there's a lot of logic possible underneath, and we built the entire tree of like, oh, what if this happens, what if this happens, what if this happens, what if this happens? And we built it and we tested it, and we got a transaction like, hey, you're getting money back. And that went into an error stream in a production situation. Because we do catch everything, and then it just goes into error, and then it's a manual fix, like, oh yeah, what do we need to do? To which account do we need to book this now? Let's build it in the actual code. So, tax refunds, those are fun. The central message here is that we often don't question our basic assumptions. Because we say, oh, we have to pay taxes, and we go and we step into it, and we go and figure out all the logic underneath. But we fail to put that first if, that first thing that we assume is fact, as the if that it is. And we don't ask that question else. Very often, as testers, we hear, our role is to ask the what if. But the what if is an imaginative if. In logic, we're asking the else. And if we confuse the imaginative if with the if here, we just keep on falling into this trap. There's another, like, this happens, we do this all the time. There's a childhood riddle that is very, very interesting in the same sense. It's thinking logically, it's thinking creatively. Who dares to do the riddle? It's a father and son going out, cycling on the road. They're hit by a car. There's an accident, the ambulance comes. they pick up the father and son, they rush them through the hospital, to the hospital. There, they enter all the emergency services, and the son is rushed into the operating room, and the surgeon enters and says, I can't operate, because it's my son on the table. How is this possible? Sorry, what did you say? Neighbor? Father and son. In this particular scenario, it is the actual father of the child. And yes, I know I already heard the answer, but... Sorry? The doctor or grandpa? No, it is not.
The surgeon is his mother.
Yes, the surgeon is his mother. And it's one of those things that sometimes you see immediately, sometimes you just kind of puzzle. I had a friend who came up with the scenario that the surgeon was actually the second father because it was a gay couple who'd had the son. There's all kinds of scenarios possible here, but it is about that logical fallacy, like how does this work? And that's what we do in testing as well. Our value as testers is to ask those imaginative questions, to question the status quo, to question the assumptions that we as a team make. I have another story about another value we really need as testers. Because we need our critical thinking. We need our creative thinking to do our role. And we need also to have the trust within the team that when we raise something, we're not dismissed. The never-ending change, as I so eloquently put it, is a change that occupied me for about 4 or 5 weeks. Because there was a bug hidden in there, and I knew there was a bug somewhere. But it was hidden well. If you did a unit test, it worked beautifully. No problem at all. If you ran it with a production file through, it stopped the system. But because of the complexity of the change, you would only see this actual change if you ran this part of the system, and then you made the change here, you saw the change there on the second business date. So it was, there were a lot of variables involved. And I know I'm not explaining this particular scenario well at the moment, but what really happened was if you ran just a few trades through, and through that entire system for the 2 days, it worked. If you ran through too much data, it just completely stopped the system. And it produced different results every single time. But because of this, because of the amount of time that it takes to run this entire test with a production file, which we don't normally do, and because I got different results every single time, my developer was like, well, you must have made a mistake in running this entire, like somewhere on the stream you must have made the mistake or changed something along the way or did something slightly different which resulted in these different values. So in this particular change, I didn't really ask the right questions about, moving on and how does this work and why does this do this? Why does it keep on stopping my system? I just pushed on ahead and dug myself in and explored and thought, this is, it's not working, but I don't know why. What we do as testers is we explore. We have our creative thinking, we have our critical thinking, and we apply that to the specific situations that we find. But a lot of our value comes from not just testing what this user requested and this feature, but taking a broader view. Associative thinking. What happens if I do this? The imaginative if. Some of the bugs that I found had been in the system for 4 or 5 years until they were discovered. And we have, all kinds of safety measures in place that we did see that data somewhere, but through this whole error stream. And that was because we missed a few jobs along the way somewhere. And we didn't have all the right checks in place. So when I went through our regression testing and analysis and explored the stream, and I saw that, hey, wait, we have a broken link here, which goes into error, and then it goes all the way through. That's weird. It's the sense of we checked if the status was an error. And we checked that for every single regression run. Is the status an error? It wasn't when we started checking, is it not processed, that we found that a lot of things weren't even being processed at all. And it's these simple things, taking the freedom to explore. Now, this is the system, housekeeping, which protects the referential integrity of our database. We have a data warehouse with mostly a 3N model for parts of the core system. And what that means is that you work with primary and foreign keys. Now, if you do that and you want to use inner joins, you want to make sure that if you have data in this table, you also have that matching data in the other table, right? Because otherwise, you need to use outer joins, and that's not that performance friendly. So we have a system in place, a piece of code that checks the tables and sees, oh, I have a foreign key relationship for this new data that came in, but I don't have that matching value. I'll create a dummy value so we can at least join. And that works beautifully, perfectly. So good, in fact, that for the majority of our users and even the majority of our IT teams, this process is something that runs automatically and is just part of the database. What people then forget is that's a configured piece of code. And if you add a new table, you need to add that piece of code to that new table to this piece of code. This is what we do as testers. We explore, we find different weird bugs, asking questions, by imagining something else, by not following the pattern, but breaking outside of that box, asking the logical else. What if it's not that way? What if it's something else? In short, this is what we do. This is what our skill set is. This is what we can apply in our work. Do you recognize any of this? You have your own stories about the bugs you failed to find, and when you analyze them, you actually found that the reason you didn't find them before is because you had a bias that led you to assume that that was the way. This is why I love to analyze all those bugs that I didn't spot. If I have a patch in production, or even in a pod environment, a pre-production environment, and that's on a piece of code I tested, I don't beat myself up for not having found it, but I do look, how did I miss this? What thinking flaw was there that made me miss this? How can I do this differently next time? And often it hides in the simplest of things. The basic assumption, if we pay tax, we can also get a refund. If a source tells me that this is the column, this is the file, it might actually contain different data than what they themselves realize. If I use logic statements, I need to make sure that I actually have the logic fully written out. Where is the or? Where is the and? Where are the parentheses around that? How does it work? And that kind of exercise is something that's also very much fun to do, not just alone, but with your fellow testers, with your team, with your developers. What assumptions are we making? Which patterns are we following? And how can we think anti-pattern? What is the associative question we can ask?
Thank you very much for the presentation.